All right, so working these problems right here, we're going to go through and work the requested problems from page 475. First of all, number 17. So in number 17, the trick on this one is to realize that the length of this segment right here is 11 minus x. Because 11 minus x plus x would equal 11. So then the setup is, I'm going to do 9 over 4 equals 11 minus x over x. We'll cross multiply and get 9x is equal to 44 minus 4x. We will add 4x to both sides, so that will be 13x equals 44, and x is equal to 44 over 13. Everybody okay with that? All right. Number 21, because this is an angle bisector, I'm going to do x over 14 equals 20 over 8. This over this equals that over that. So side touching the angle over the segment, side touching the angle over the segment. So that's 8x is equal to 80. X is equal to 10. Oh, I'm sorry. You're correct. And that would not be right. So that's going to change that number, which will drastically change that answer. So 14 times 20 is 280. And then divide that by 8, and you get 35. Much better. Everybody okay with that one? Stop me if you have a question. So 25 through 29-ish, we are using the figure at the right to complete our answer. So we know that these angles bisect each other, so that's going to mean something about the triangle figure that's made at the top or any triangle down the bottom. We also know that these are all parallel lines, so that can tell us some information too. So RS is from here to here, and JR is from here to here, and KJ is this side up here. So in number 25, if I were just looking at JKS and this being an angle bisector, it would be RS over KS is equal to RJ over JK, or JR over KJ. So number 25 fills that box in with KS. Does anybody need me to go through and work any of the others out of this?
Can you do 33 and 34?
Okay, I'm talking about 25 through 30 right now. I will do those, yes. So now that you know how to set it up, do you need to see any others out of this area? Okay, good. So for 33, all the lines are parallel. So I'm going to do 4x over 5x is equal to 4x plus 8 over 6x minus 10. You're going to get quadratics when you do this. I don't want to work with quadratics, so I'm going to simplify this ratio to 4/5.
Can you do that?
I mean, can't you cancel x over x? Is 4x plus over 5x the same thing as 4 over x?
That would be a lot easier.
Yeah. So, I mean, do you want me to go through and work it without doing that?
We can do that. That's a lot.
Yeah.
I mean, that
So
would-
4 times, you could do this. I cannot cancel the x's from here. Does everybody understand why?
Yeah.
Okay.
Wait, why?
Because these are parts of an expression, and that just doesn't work that way. So 4 times 6x minus 10 is equal to 5 times 4x plus 8. So I'll distribute. That'll be 24x minus 40 is equal to 20x plus 40. I'll subtract 20x from both sides, and that'll give me 4x minus 40 is equal to 40. I'll pull up Google. Let me put this up here so I can continue on. So a lot of people, when they see 40s on both sides, they just cancel them. But really, you're adding 40 to both sides. So 4x is equal to 80. And then divide by 4, and x is equal to 20. I think if you quadraticed it, you've got a 20 as a positive answer and some negative answer that you threw away. I don't know. I didn't quadratic it, so I don't know what you got. Everybody okay with this? Number 34. I'm going to set it up as 7x over 5x is equal to 10x minus 4 over 6x. I'll go ahead and quadratic this one. Just to show you it can be done. So that'll be 42x squared is equal to 50x squared minus 20x. So I will go ahead and subtract 42x squared from both sides, putting a 0 on one side. So that's 8x squared minus 20x equals 0. And then I could use this as A and this as B and 0 for C in the quadratic equation. So A equals 8, B equals negative 20, and C equals 0. That's going to be pretty easy to solve. So that's going to be negative a negative 20, which is 20, plus or minus the square root of negative 20 squared minus 4 times 8 times 0, all over 2 times 8. So that's 20 plus or minus the square root of negative 20 squared is just going to be 20 over 16. So that's 20 plus 20 over 16 and 20 minus 20 over 16. But this is 0 over 16, and you can't have a side length of 0. So I'm going to throw that one out. So 20 plus 20 over 16 is 40 over 16, which reduces to 20 over 8, which reduces to 10 over 4, which reduces to 5 halves.
Okay, so what's your deal with the decimals on this chapter? Because I got 2.5.
So 2.5 is fine because 2.5 terminates. That's still an exact answer. So my deal with the decimals on this chapter is the same as my deal with the decimals on any chapter. Everybody okay with that? You get the same answer if you cancel out the x's and cross multiply. Number 35, 12 over 7x equals 2x plus 2 over 5x minus 1. This one you can't cancel anything out. So I'll cross multiply. 7x times 2x is 14x squared plus 7x times 2 is 14x. It's a horrible 14. 12 times 5x is 60x minus 12. I think I'm going to move everything on this side of the equation over to the other side. So I didn't have an x squared term to subtract off by. 14 minus 60 would equal 46. So that's going to be a minus 46x plus 12 equals 0. You can always factor out a monomial to start out your problem. So I could factor out a 2, and that's 7x squared minus 23x plus 6. That makes the numbers a little bit easier. Factor pairs of 4. Oh, no, I don't want to factor this. I'm going to use the quadratic. So I'm going to use A is equal to 7, B is equal to negative 23, and C is equal to 6. All right, so that's going to give me negative 6 plus or minus the square root of 6 squared. Nope.
Wait, I thought it was
Completely wrong there. positive 23 plus or minus negative 23 squared minus 4 times 7 times 6 all over 2 times 7. So that's going to give me 23 plus or minus the square root of 529 minus 168 over 14. So that's 23 plus or minus the square root of 361 over 14. The square root of 361 turns out to be 19. So that's 23 plus 19 over 14 and 23 minus 19 over 14. So at this point, I think I still have to work both of them and plug them back in and see if they're both valid answers. So 23 plus 19 divided by 14 gives me 3. And 23 minus 19 divided by 14 gives me 2/7. Now, the problem with 2/7, is it 2/7?
That's what the answer is.
Okay, 4. Yeah. So if I do 5 times 2/7, that's 10/7. So that's still going to be bigger than 1. So that's an okay solution. So actually, there were 2 different solutions to this problem. Either 3 or 2/7 would work. So if you get 2 positive answers, they're both acceptable. If you get 2 negative answers, that means the problem didn't have a solution. Everybody okay with that? All right. Suppose triangle VLQ is similar to PSX if the measure of angle V is equal to 48 and the measure of angle L is equal to 80. What is the measure of angle X? Well, V and L and P and S. Well, crap, I don't have enough info. Oh, wait. If I've got 2 angles in a triangle, can't I find the third angle? Yeah. So let me just sketch a triangle here real quick. I don't care that this looks isosceles because it's just a sketch. This is not drawn to scale. And I'll label this VLQ. And then I'll make another one. So, well, let's go ahead and write the angles in here. So V is 48. L is 80. And Q would be what?
Yeah, that's it.
52. So all of the angles in similar triangles are actually congruent. So if Q is 52, then X is also going to be 52. So since the triangles are similar, angle Q is congruent to angle X, which means their measures equal each other. And so the measure of angle Q, I can substitute in 52 for the measure of angle Q, and that tells me what the measure of angle X is. And this came from 180 minus 80 minus 48. Everybody okay with that? And then finally, in the diagram at the right, PR congruent to QR. So this angle congruent to this angle. For what value of X is TS parallel to QP? So TS QP. Well, that actually can be computed. Because if these two sides right here are congruent, what type of triangle do you have? And if you know the vertex angle of an isosceles, can't you find the base angle by doing that? So 180 minus 56 is 124. Divided by 2 is 62. So doesn't that make this 62 and this 62 since they have to be the same? I mean, I guess I could have done x plus 56 equal 180. And that gives you 2x is equal to 124 and x is equal to 62. So if those both were the same, there you have it. So now, if this is 62 and these two lines are parallel, what do you know about x and 62? They're supplementary. So x plus 62 has to equal 180. So therefore, x needs to equal 118. Everybody okay with that? So these are what I would call